It all started with a dream. Not a fuzzy, half-remembered dream, but a clear, powerful vision. A bishop or a king would decide their city needed a house of God. Not just any house, but the biggest, most beautiful one anyone had ever seen. A building that would scrape the sky and fill with light. A building that would declare the glory of God and the power of their city. But a vision is just an idea. Turning that idea into a mountain of carved stone was the real challenge. It was a job for the master mason. The master mason was the most important person on the construction site. He was the architect, the engineer, and the project manager all in one. He didn't have computer-aided design software or complex physics calculators. He had his mind, his experience, and his geometry. He understood the secret language of shapes. He knew how a triangle could create strength and how a circle could form a perfect arch. This knowledge was often a closely guarded secret, passed down from master to apprentice over a lifetime. It was a kind of magic, but it was a magic based on mathematics and the real-world properties of stone. When a new cathedral was commissioned, the master mason would be hired. He would walk the site, feeling the ground, observing the sun's path. He would think about the stone available from local quarries. Then he would start to plan. There were no blueprints as we know them today, no giant rolls of paper with every detail drawn out. The plan existed in several places. First, it was in the master mason's head. He held the entire complex three-dimensional structure in his imagination. To communicate this vision, he used a few key tools. He might make a small model out of wood or wax to show the bishop what he intended to build. This helped everyone visualize the final product and, more importantly, helped secure the money to build it. Cathedrals were incredibly expensive. The funding came from the church, from wealthy nobles, and from the townspeople themselves. People would buy their salvation, they were told, by donating to the cathedral. They gave what little they had, believing their contribution would earn them a place in heaven. Relics of saints were also a huge source of income. A cathedral with the fingerbone of a famous saint could attract pilgrims from all over Europe, and their donations would keep the construction going for another year. The real blueprints were often full-scale drawings made right on a large, flat floor of plaster called a tracing floor. Here, the master mason would use a giant compass, straight edges, and ropes to draw the exact shape of an arch or the curve of a vault rib. This wasn't a drawing of the whole building, but of its most important components. From these full-size drawings, carpenters would make wooden templates. These templates were the lifeblood of the project. A template for a specific arch stone could be taken to the quarry or the mason's lodge. A stonecutter could then place the template directly on his block of stone and know he was cutting it to the precise shape and angle required. Every piece had to fit perfectly with its neighbors. There was no room for error. The whole system was based on proportion. The master mason knew that the width of the nave should have a certain relationship to its height. The size of a pillar would determine the size of the arch it supported. Everything was connected by a simple, elegant set of geometric rules. This is why cathedrals feel so harmonious and balanced, even with their staggering complexity. It's not an accident. It's the result of a single, coherent vision, guided by geometry and executed by hundreds of skilled hands, all working from the same simple templates derived from the master mason's drawings on the tracing floor. The grand plan wasn't on paper. It was in the templates, in the shared knowledge of the craftsman, and in the mind of the one man who could see the finished cathedral before a single stone was laid. A cathedral site was a city within a city. It was a noisy, dusty, and incredibly organized place teeming with hundreds of men. At the top of this pyramid was the master mason, but he couldn't build it alone. He commanded a small army of workers, each with a specific job. This workforce was structured in a strict hierarchy, and the heart of their world was the mason's lodge. The lodge wasn't just a shed to store tools. It was the workshop, the break room, and the union hall. Inside, protected from the wind and rain, the more skilled masons would do their finest work. It was here that apprentices learned their craft, where wages were paid, and where disputes were settled. It was a community, a brotherhood of builders bound by their shared skill and secret knowledge. The hierarchy was clear. Under the master mason were his wardens, who acted as foremen. They supervised different parts of the project, ensuring the work was done to the master standard and that the flow of materials was constant. Below them were the journeymen, or fellow craft masons. These were the skilled, time-served builders. They had completed their apprenticeship and were now free to travel from job to job, earning a daily wage. They were the ones who could read the wooden templates and cut a complex voussoir, one of the wedge-shaped stones that form an arch, with precision. There were two main types of stonemasons. The hewers or rough masons did the heavy, less precise work. They would quarry the stone and shape the basic blocks for the walls. Then there were the Freemasons. They were the elite. They worked with freestone, a type of fine-grained sandstone or limestone that could be cut and carved in any direction without splitting. These were the artists who carved the delicate tracery for the windows, the statues of saints, and the grotesque gargoyles. At the bottom were the apprentices. A boy would start his apprenticeship around the age of 13. He would be bound to a master mason for about 7 years. His first jobs were simple carrying tools, mixing mortar, and watching. Always watching. He would learn by doing. He'd be taught how to use the tools, how to read the grain of a stone, and how to feel for its strengths and weaknesses. It was a long, hard education, and many didn't make it. But those who did would become journeymen, ready to make their mark on the world. Of course, the masons weren't the only ones on site. There was a whole ecosystem of other trades. Carpenters were essential. They built the scaffolding, the timber frames for the roofs, the complex wooden centering that supported the stone arches and vaults while they were being built, and the all-important templates. Blacksmiths were constantly at work, sharpening the mason's tools. A chisel would become dull after only a short time cutting stone, so the smithy was one of the busiest places on site, its hammers ringing out from dawn till dusk. And then there were the laborers. Unskilled but strong, they were the muscle of the operation. They dug the foundations, carried hods of mortar up rickety ladders, and powered the great wooden cranes that lifted the stones into place. Their work was brutally hard and poorly paid, but without them, the cathedral would have remained a pile of rocks on the ground. Everyone had their place, from the master mason with his compass and square to the laborer with his shovel and bucket. Their tools were surprisingly simple. You wouldn't find any power tools here. A mason's toolkit consisted of a few key items. The mallet, usually made of wood, provided the force. The chisels did the cutting. There were different types for different jobs. A point chisel was for roughing out the stone. A claw chisel, with its toothed edge, was for smoothing the surface. A flat chisel was for the final, fine finish. To ensure accuracy, they used a metal square to check for right angles, a plumb line, a weight on a string to check for verticality, and a level to check for horizontality. With these basic hand-powered tools, these men shaped millions of tons of stone with a precision that is still astounding today. A cathedral is made of stone. That's an obvious statement, but getting that stone from deep within the earth to high up on a wall was one of the greatest challenges of the entire project. It was a massive logistical feat that required immense planning and backbreaking labor. The journey of a single stone tells the story of the cathedral itself. It all began at the quarry. The master mason didn't just choose any stone. He had to be a geologist. He needed stone that was durable enough to withstand the centuries, but soft enough to be carved. He considered its color and how it would look in the finished building. Most importantly, he considered its location. Transporting stone was slow, dangerous, and incredibly expensive. The best quarry was often the closest one. Many great cathedrals had a quarry opened specifically for their construction, just a few miles away. Quarrying was hard, relentless work. Men would work in the open, exposed to the elements, their lives a cycle of sweat and dust. They didn't have dynamite, they had to split the stone from the bedrock using simple but clever methods. They would first cut a line of grooves into the rock face with picks and hammers. Then, they would drive wooden wedges into these grooves. They would pour water over the wedges. Over several hours, the wood would swell, exerting a slow, immense, and irresistible pressure on the stone. Eventually, with a great groaning sound, a massive slab would break free. Later, iron wedges were used, which were faster and more efficient. Once the slab was free, the work was far from over. A huge block of raw stone was too heavy to transport easily. So, the rough shaping was often done right there at the quarry. Masons, known as hewers, would work on the blocks, cutting them down to a more manageable size. They might even use the wooden templates sent from the main construction site to rough cut the stones into their approximate final shapes. This saved a huge amount of effort later on, as it meant they weren't transporting waste material. Each skilled mason had his own personal mark, a simple symbol like a cross, an arrow, or an initial. He would carve this mark onto every stone he finished. These masons' marks served several purposes. They were a form of quality control. If a stone was poorly cut, the master mason knew exactly who to talk to. More importantly, they were how the masons got paid. A clerk would count the number of marked stones from each mason to calculate his wages. It was a simple and effective system of accountability. Today, you can still see these marks on the walls of medieval cathedrals, a quiet signature from a man who worked on the building 800 years ago. Now came the hardest part, transportation. Moving a block of stone that weighed several tons was a monumental task. For short distances over land, the primary method was an ox cart. These were sturdy, two-wheeled carts pulled by a team of slow, powerful oxen. The journey was agonizingly slow. The heavy carts would churn up the dirt tracks that passed for roads. Sometimes new roads and even bridges had to be built just to get the stone from the quarry to the cathedral site. A journey of just 10 miles could take days. Whenever possible, they used water. A barge floating on a river could carry far more weight than an ox cart, and with much less effort. If a quarry was near a navigable river, it was a massive advantage. The stones would be loaded onto barges and floated downstream to the nearest point to the town. From there, it was back to the ox carts for the final leg of the journey. This entire process, from quarrying to final delivery, was the project's biggest bottleneck. The masons on site could only build as fast as the stone arrived. A bad winter, a flooded river, or a broken cart could bring work to a standstill for weeks. The slow, steady procession of stone was the lifeblood of the cathedral. With a steady supply of stone arriving, the cathedral could begin to rise from the ground. Building upwards was a slow, methodical process, a dance between brute force and architectural genius. It required a deep understanding of how to defy gravity, one stone at a time. Everything started with the foundation. You can't build a massive stone structure on soft ground. The builders had to dig. They would excavate huge trenches, sometimes 30 feet deep, all the way down to bedrock or a stable layer of gravel. This was done entirely by hand, with picks and shovels. These vast trenches were then filled with a dense layer of rubble and rough stone, packed tightly together and sealed with mortar. The foundation was the most important part of the building, and yet it was destined to be completely invisible. A mistake here, a weakness in the foundation, could cause the entire structure to collapse generations later. The masons spent years on this crucial, unseen work, laying the groundwork for the glory that would rise above. As the walls grew higher, the workers needed a way to get up there. This was the job of the carpenters, who constructed a complex web of scaffolding around the growing structure. It was a forest of timber poles lashed together with rope. Planks laid across the poles created walkways and work platforms. This scaffolding wasn't just a ladder. It was a temporary world, a vertical village that grew alongside the stone walls. It was flimsy and dangerous by modern standards, but it was essential. It allowed masons to stand exactly where they needed to be, to set each stone perfectly in its place. But how did they get the stones up there? A man can't carry a 1-ton block up a scaffold. The answer was one of the most ingenious machines of the Middle Ages, the treadwheel crane. This was a large wooden crane with a long rotating arm. Its power came from a giant wooden wheel, like a hamster wheel for humans. 2 men would walk inside this wheel, their combined weight and motion turning the drum that wound the main lifting rope. It was a simple, effective, and incredibly dangerous form of human-powered engine. A slip or a stumble could be fatal, but with these cranes, the builders could lift massive stone blocks, buckets of mortar, and heavy timber beams hundreds of feet into the air. As the cathedral climbed higher, the builders employed a set of brilliant architectural innovations that defined the Gothic style. These weren't just for decoration, they were engineering solutions to the problem of building taller and brighter than ever before. The first was the pointed arch. Unlike the classical rounded arch, which pushes outwards as well as downwards, the pointed arch directs the weight of the structure above it more efficiently downwards. This meant the walls didn't have to be as thick and solid, and the building could reach much greater heights. The second innovation was the ribbed vault. Instead of a heavy, solid stone ceiling, the Gothic builders created a skeleton of stone arches, or ribs, that crossed each other. The curved spaces between these ribs were then filled in with much lighter, thinner panels of stone. This made the entire roof system significantly lighter, reducing the amount of force pushing outwards on the walls. It was a clever way to create a strong, fireproof ceiling without immense weight. The third and most famous innovation was the flying buttress. This was the real game changer. The pointed arches and ribbed vaults still exerted some outward pressure on the thin walls. If left unsupported, these walls would eventually buckle and collapse. The flying buttress solved this problem in a spectacular way. It was an external stone arm that flew from the upper part of the wall over the side aisle to a massive stone pier on the outside. This arm caught the outward thrust of the vaults and channeled it safely down the pier and into the ground. It was like an external skeleton for the building. This brilliant solution freed the walls from their load-bearing role. They no longer had to be thick and solid. They could be opened up, filled with vast, beautiful windows of stained glass, flooding the interior with divine light. These three elements, the pointed arch, the ribbed vault, and the flying buttress, worked together as a system. They created a structure of incredible height and light, a stone skeleton that seemed to defy its own weight. And holding it all together was mortar. The medieval mortar was a simple mix of lime, sand, and water. It wasn't a fast-setting superglue. It cured very slowly over months or even years. This slow cure gave it a slight flexibility, allowing the massive building to settle and shift over time without cracking. Each stone was laid on a thick bed of this mortar, carefully placed by a mason on a high scaffold, one piece of a giant skyward-bound puzzle. The main structure was up. The skeleton of stone stood against the sky, a monumental achievement of engineering and labor. But it wasn't a cathedral yet, it was still a shell. The final stage was to give it a soul, to transform the cold stone into a space of awe and worship. This was the work of the artists and finishers, the men who brought beauty and meaning to the raw structure. While the rough masons built the walls and the Freemasons shaped the arches, a different class of carver got to work. These were the imagers, the sculptors who could make stone come to life. They worked on the finer details that would tell the stories of the Bible to a population that could not read. They carved the rows of saints and prophets that lined the doorways, each with a distinct personality. They created the dramatic scenes on the tympanum, the semicircular space above the main entrance, often depicting the Last Judgment with its vivid images of salvation and damnation. Their work was everywhere. They carved the capitals on top of the columns with intricate patterns of leaves, vines, and mythical beasts. And high up on the roofline, they created the gargoyles. These weren't just decoration. They were functional waterspouts designed to throw rainwater clear of the walls to prevent erosion. But the Masons used them as an opportunity for creativity, carving them into grotesque demons, comical animals, and tormented human figures. It was a chance for a bit of freedom and personal expression in a highly structured project. While the carvers worked on the stone, another group of craftsmen was creating the cathedral's most stunning feature, the stained glass. The great innovation of the flying buttress was that it allowed the walls to be filled with windows. These weren't just openings for light, they were vast, colorful storybooks. The process was complex. A master glazier would first draw a design, called a cartoon, on a large whitewashed table. Glassmakers would create colored glass by adding metallic oxides to the molten sand, cobalt for blue, copper for red, manganese for purple. The glass was then cut into the precise shapes from the cartoon. The artist would paint details like faces and folds of cloth onto the glass pieces with a special enamel. These pieces were then fired in a kiln to make the paint permanent. Finally, the hundreds of small pieces of glass were fitted together, held in place by strips of lead. The completed panel was then lifted into the stone tracery of the window. When the sun shone through, the interior of the cathedral was transformed into a kaleidoscope of rich, jeweled light. For the medieval person, this light was not just beautiful, it was a symbol of the divine presence. Building a cathedral was not the work of a few years, it was the work of generations. The master mason who laid the foundation stone would never see the final spire completed. His sons and his sons' sons would continue the work. A stonemason might spend his entire life working on a single building. This incredible length of time gave the project a sense of continuity and permanence. It wasn't just a job, it was a legacy. The cathedral became the heart of the community. It was a center of religious life, of course, but it was also the center of civic life. It was a source of immense pride, a symbol of the town's wealth, power, and piety. Its bells marked the hours of the day, calling people to work and to prayer. It was the biggest building anyone had ever seen, a constant, tangible link between their daily lives on earth and the promise of heaven. Today, we look at these cathedrals with a sense of wonder. How did they do it? They did it with simple tools, a profound understanding of geometry, and an incredible amount of human effort. They did it with a social structure that allowed knowledge to be passed directly from master to apprentice. They did it with a faith that inspired people to dedicate their entire lives to a single project, one they knew they would never see finished. Each cathedral is not just a building, it is a testament to the ingenuity, the artistry, and the endurance of the medieval stonemasons who, stone by slow stone, built heaven on earth.